Welcome back. In earlier video you understood about how to run a MapReduce job and the basics of MapReduce. We'll continue from same point and I'll make you to understand about two important topics in this video. First one is ToolRunner, why ToolRunner we'll see, and also we'll understand about the new MapReduce API and what are the differences between old MapReduce API and new MapReduce API. So first let us start about ToolRunner. Before I talk about ToolRunner, let me go to the same program, MapReduce program, the word count program, and see some more details. By default, how many reducers were executed? The default reducers are 1. How many mapper tasks will be executed? It depends upon the number of input splits or number of blocks. So in my earlier case, what I did is I executed my jar like this. What hadoop? I think it's there already, the command. I executed my jar like this, hadoop jar word cont'd.jar, and this is a driver class, this is the input directory. All the files in this input directory will be taken up, and this is the output directory. Now what I want to do is I want to check if I run the same program with same output folder, what happens. Let us see. See, I got an exception. What is the exception? It is saying file already exists. User slash siva slash word cnt out already exists. This is the exception. So first of all, whenever I submit a MapReduce job, Hadoop will check whether this output directory is already existing or not. If it is already existing, it will throw this exception, because by mistake we should not override the output of previous MapReduce job. The MapReduce jobs are really costly. They will take lot of time to execute. On say if I am processing some 1 terabyte of file, it might take a lot of time to execute. Somebody in your team should not by mistake run the same program with same output directory. The output might be overridden, is it, if we specify same output directory? So by mistake also somebody should not run it. If somebody runs also, the output directory should not be overridden. That's the reason why MapReduce will throw an exception. MapReduce engine will throw an exception, or in this case actually not MapReduce engine, it is the job client which is throwing an exception. Whenever you are submitting a job, the job client itself will check whether the output directory is already present in HDFS or not. If the output directory which you mentioned is already existing, exception will be thrown by the client itself. Okay, so now we understood about what happens when you execute a MapReduce job with same output directory. Now I will change the output directory. If I execute, it will work, but before I execute it, I want you to understand how many reducers were there and how many mappers will start when I run this. In Shakespeare folder, how many files are there? Let me show you. Hadoop fs-ls/user/siva/Shakespeare. There should be 5 files, and each file is less than 64 MB. So basically 5 blocks, 5 individual blocks. That means 5 input splits. That means 5 map tasks. So when I start this MapReduce job, there will be 5 map tasks. And how many reducers? By default, there will be 1 reducer. If you want to specify how many number of reducers should run, what you can do is conf set num reduce tasks. I will set as 2. So I am setting that number of reduced tasks that should be started as 2. So let me rerun the same program, but before that let me remove the jar and recreate the jar because the files are modified. So jar, first of all ls, only the classes are there, then jar dash cvf word cnt dot jar star, everything in this directory will be added. So I have the jar again. Now I will submit the same, but the output directory is different, word cnt out2. Let me execute it. We'll observe how many reducers will start. Okay, so this will take some time for completing this map reduce job. I'll pause the video. The job completed. Let us see this output, and in the output if you see how many number of reduced tasks were launched. Two reduced tasks were launched. Okay, let me check the output. I'll browse the file system, user /siva /word cnt out2. How many part files are there? 2 part files. So part file is output of each reducer. First reducer has outputted this part 0000, second reducer output is part. So if the number of reducers is 2, the number of files given as output will be 2. So let me check part 1. It's containing some keys and values, and part 0 will contain some keys and values. So let me make you understand what happened when there are 2 reducers. Now how many map tasks? 5 map tasks and 2 reducers, right? So let me just draw the diagram. So assume that this is my cluster which I am drawing right now. My cluster, let's assume that there are 5 data nodes, 5 slave machines and 2 master machines. Here name node is running, here job tracker is running. Now for the job which is submitted, there are 5 blocks, right? Assume that block 1, block 2, block 3, block 4, block 5. Okay. Now when I submit my job, 5 map tasks will be executed on each slave machine, and let's assume that there is 6th slave also. On this the reducer task will be started. Now, assume that there are 7 slaves. Okay, so on this 2 slave machines, reducer 1 and reducer 2 will start. So output of map 1 will be some key value pairs, output of map 2, map 3, map 4, map 5 output, each mapper will output some key value pairs. So there are some key value pairs, there are some key value pairs, there are some key value pairs. Each map task has outputted some key value pairs. After mapper is completed, what shuffle and sort phase is there, right? During shuffle phase, there is something called as partitioner, which will partition the keys for different reducers. Partitioner. How many reduce tasks are there? Will be there 2 reduce tasks. There are 2 reducers. So there are 2 reducers, right? Assume that these are the reducers. Okay, reducer 1, reducer 2. Now some key value pairs should go to reducer 1, some key value pairs should go to reducer 2. What the partitioner will do is, partitioner will by default use hash values, hash code of the keys. Every Java object has a hash code, is it? Unique hash code. So the default partitioner is called as hash partitioner. We'll see how to create our own partitioner also next. This is a default partitioner. What it will do? It will take the hash code of the key, and based on the hash code, it will send some keys to this reducer and some keys to this reducer. So the key value pairs are partitioned among the reducers by using a hash partitioner. Okay, so some key value pairs will go to first reducer, some key value pairs will go to second reducer, right? So based on the hash code, it will decide which keys should go to first reducer and which keys should go to second reducer. Okay, so we'll see more on partitioners next. So that's how each reducer gets its own input, its own key value pairs. Okay, earlier when there was one reducer, there also hash partition was executing, but all the key value pairs will go to single reducer. But now as there are two reducers, the hash partitioner will partition the keys based on their hash codes. We'll see how to write our own partitioner also next. So this is what has happened. Okay, once you understand this, there is a problem with the code which I wrote. Let me tell you. Am I not hard coding the number of reducers? Yes, I am hard coding the number of reducers. I don't want to hard code. So what I want is, I want the number of reducers to be dynamic. So the user who is submitting the job should decide how many number of reducers has. Suppose if he is submitting a file of size set 1 terabyte, he might want 10 reduce tasks. If he is submitting a file of say 1 GB, he might be okay with 2 reducers. So dynamically the user who is submitting the job should be able to decide how many number of reducers he requires. What we can do is, we can pass it as command line argument, one option, args of show whatever. But if I have written my program which will take args of 2 here, the user who is submitting the job should know as which argument that reduce task should be passed. Reduce task, the number of reduce tasks should be passed as third argument, is it? 0 is the input argument, 1 is output directory, and 2 is the number of reduce tasks. So he should remember, or he should be aware at which index the argument should be passed to the command line. It will be good if there is a standard way instead of remembering the index of the input argument. So that's where the tool runner comes into picture. So let us discuss about tool runner. You can use tool runner inside a MapReduce driver class. You need not use tool runner, but that is a best practice. Using tool runner is a very best practice. Okay, tool runner internally uses a class called as generic options parser class internally, which will parse the arguments passed to command line. We will see about other use case for distributed cache later. So what is this tool runner? Let me show you. If you are writing your Java class, a driver, Java driver, using tool runner, you have to write it like this. Your class, the driver class, should extend configured and implement an interface called as tool. If your class is implementing tool interface, you should write the job submitting code inside the run method. Okay, and inside run method is taking arguments array, string array as arguments. So in the same class, I am having a main method which is taking string array as arguments. So in my main method, what am I doing? I am calling tool runner.run. Run method takes the first argument. The first argument should be a class which is implementing tool interface. Okay, tool runner.run is used to run a tool. Any class which is implementing tool interface is a tool. So I am passing my class word count using tool runner and arguments. So whatever I am passing through command line will be passed as arguments to run method as well. Okay, observe what is the code I am doing. See, I am calling getConf. Earlier, without implementing tool interface or extending configured, we used to create new configuration. I told that whenever you say new configuration, it will load all the default values. But now I am extending configured, right? So in the superclass configured, there is a method called as getConf. This getConf method in the superclass is creating a configuration object, and it will do something else as well. I'll tell you. GetConf will give you the configuration object. Then I am creating an object called as generic options parser, passing the configuration object and the arguments, and I am calling a method called as get remaining args. So it is returning me a string array. I am checking if the other arguments dot length is not equals to 2. I am printing the usage, how to use this class. We'll come to this. And whenever I am creating a job configuration object, I am passing this configuration object. Okay, I am passing this configuration object, then setting the job name, and all are same, right? Rest all are same. Am I setting the number of reducers? No. So now what I could do is, once I have written a class implementing tool and extending configured, how to run this driver, how to run this driver to submit job. Let us see. What you can do is, whenever you are submitting a MapReduce jar, this is a command hadoop jar, this is a jar name and the driver class name, -d, and you can pass some configurations, MapReduce dot reduce dot tasks. So this is the way you can pass the number of reduced tasks. So whatever you are passing, the options -d options, they will be automatically recognized by the tool runner, right? So in this getConf method, if you see, in this getConf method, it is creating a configuration object, right? So the configuration object will take the command line argument into consideration, and it will set the number of reducers. So let me show you practically through code. I'll explain more through code. Let me go through the command line. I'll start my master. I already have the same code using ToolRunner, word count using ToolRunner. So here I am extending configured and implementing tool. This is the same thing whatever I have shown you in the presentation. Now how to run, how to submit a job using this tool runner, let me show you. What I will do is, already the jar is the same jar, okay? So hadoop jar word count dot jar, and the class name, driver class name is what, in dot co dot way to learn dot word count using tool runner. So this is a class which is containing main method. In the main method we are calling toolRunner.run and passing the object which is implementing tool interface. This is the one, right? Now this is a class, and I want to pass some arguments to this class. -d map red dot, what is the configuration name, map red dot mapred dot reduce dot tasks. I will submit mapred dot reduce dot tasks is equals to 3, better 2. Then what is the input directory, /user slash Siva slash Shakespeare space output directory slash user slash Siva slash word count 3. Let me submit. So this will submit the map radio job. It will take some time. I'll pass my video and I'll come back. So the job is now complete. Let us see. How many reduce tasks are launched? Oh, 3. Actually, I gave only 2 reduce tasks, right? I have configured. Let me see. You can see here. Where did I give? Where did I give? No, this is the previous one. And now, okay, -d map.reduce task equals 2. But I am seeing the number of reduced tasks are 3. Can you guess why? So actually, due to speculative execution, my job tracker has launched one more reduced tasks. Even if you see here, the number of map tasks is 6, but how many files are there? Only 5. I expect the map tasks to be 5, but 6. It's all due to speculative execution. How do I prove that the number of reducers are 2 only? Let me see the output directory word count 3. See, there are 2 part files. That means this proves that there are actually 2 reducers only. But due to speculative execution, one more reduce task was started. One of the reduce tasks was ignored. Okay. So you saw that if you want to specify the number of reduce tasks through command line, this is the way to specify. Whatever arguments, -d arguments, whatever I am passing to the tool runner are automatically taken care into consideration, are automatically set. See, in my main method, what am I doing? I am passing ToolRunner.run. I am passing the class which is implementing tool, and I am passing the arguments. So whatever -d options I am passing, those are recognized, and in this getConf method, which is inherited from configured, in this getConf method, those -d options are taken, and the number of reducers are automatically set. Here if you see in my job configuration, I didn't set the number of reducers manually. The number of reducers are set automatically inside the getConf method by retrieving -d options. Okay. Now you might be wondering, hey, how do I remember this name? Key name map.reduce tasks. What all other configurations can I do? So where do I find the actual configuration parameter names? The answer is, you can go to these URLs for seeing some MapRed defaults, MapReduce defaults. This is the URL. Let me just open it. I'll just open it from the Apache documentation. So reduce dot tasks, reduce dot tasks dot what was the key? Sorry, MapRed reduce dot tasks, MapRed dot reduce dot tasks, MapRed dot reduce dot tasks. Is there any other reduce dot tasks? MapRed dot task tracker dot reduce dot tasks. By default, I can see somewhere that the reduce tasks will be 1. The default number of reduced tasks will be 1. Oh, I think this is the default for MapReduce 1. Let me just show you where the default values for MapReduce version 1 are present. These are for MapReduce version 2. What are the defaults for MapReduce version 1? Yep, this is a URL actually. So I'll just open for MapReduce version 1. We'll see MapReduce version 2 later. So default values for MapRed version 1 is present here. Let me just check the value for reduce MapRed.reduce.tasks number 1. So default number of reduced tasks per job. Okay. So in this XML, in this HTML file, these are the default properties available. So if by default these are default values which are loaded whenever you say new configuration in your job. Earlier in my word count earlier, if you see, without using ToolRunner, this is my driver. I was creating a new configuration object. So if I use this one, the default value will be what? The number of reduced tasks will be 1. So if I want, I can actually set the number of default reduced tasks in MapRed-site.xml if I want. But if I want to programmatically configure the number of reduced tasks, I can pass them through command prompt like this if I am using ToolRunner. This is per program. If you want to set the default values, where do you configure this property? MapRed related property in MapRed-site.xml you can configure. That will be the global one. If you want to configure only for this job, this is the way if you are using ToolRunner. Like that, you can pass the value for any of the property present in this configuration dynamically through command prompt if you are using ToolRunner. Okay. So that is the use of ToolRunner. So it is always recommended to use ToolRunner in your driver code, because you will be able to pass some configurations through command prompt. If you want to override any default configurations through command prompt, you will be able to do so by using a command line like this. Or what all you need to do is -d property name equals to the value. You have to write like this. Hope now you understood about ToolRunner. Okay. Or instead of passing each and every property like this, you can specify an XML with all the values by using -conf folder. Okay. And you can configure all the properties in -conf folder. You can write all the properties in XML file just like MapRed-site.xml. You can pass the configuration file with the values, and you can use -conf also for this hadoop command. So similarly, if you want to specify what is the default URL for name node, as you know, this is the property for name node, right? If you want to pass a value through command prompt, you can pass -d fs.default.name equals to the URI. Okay. So using ToolRunner will be very helpful. So it is recommended practice. So now what you can do is you have a lab for ToolRunner. Let me open the documentation. Yep. How to use ToolRunner. Here is the lab documentation provided to you. By following this documentation, you will be able to execute the programs. Okay. Here I have shown you how to use ToolRunner. Okay, till now you understood how ToolRunner works. Now let me show you the next topic. What is a new API? So in Hadoop, they have introduced a new API to simplify the development. When Hadoop version 0.20 was released, a new API was introduced it was designed to make the API easier to evolve in future. This new API favors abstract classes over interfaces. So in earlier version, to write a mapper, we were implementing some interfaces like reducer, and for mapper we need to implement mapper interface. But starting in new API favors abstract classes over interfaces, and old API was deprecated. But as the new API was not absolutely feature feature complete in Hadoop this version. Old API is still not deprecated because most of the developers still use old API. So old API is also there and new API is also there. The old API is not deprecated now. So what are the differences between old API and new API? Let us see the differences. In old API, the packages were from hadoop.mapread, but in new API the classes are inherited from hadoop.mapreduce. See the difference. This is mapread and this is new. In the new API it is mapreduce. And in the driver code, what we used to do is we used to create one object called as jobconf. This single object represents job object, job definition as well as configurations. Job configuration and job details are present in single object. But in the later version, the new API, configuration object is different and job object is different. And whenever you are creating job object, you are passing the reference of conf. So configuration is separated and job object is separated in new API, but whereas in old API, there was a single object representing job configuration. And in new API, we need to set jar by class. We'll discuss more on set jar by class later, but you need to set jar by class. Whereas the class name was passed as a constructor argument in old API. And in old API, we used to submit a configuration by using job client.runJob. But now to submit a job, we use job.waitForCompletion true. If you say wait for completion true, then the client program will wait until the MapReduce job is completed on the cluster. If you pass false, the client will terminate even though the job is executing on the cluster. So if you want the client to run asynchronously, you can pass false. The client will not wait until the job is completed. This is one difference in driver code. And coming to mapper code, in old API, your mapper should extend MapReduce base and implements mapper. But these all classes belong to which package? MapRed package. In new API, my mapper just extends mapper. Mapper is a class belonging to this package. Okay. And see the method also, the map method, it takes key type, value type and context. But whereas the old method will take key type, value type, output collector and reporter. We'll see the code next. Similarly in reducer, your reducer in old API was extending MapReduce base and implementing reducer. But in new API, the reducer will extend reducer and reduce method takes key type, iterable of values and context. Whereas this reduce method was taking key type, iterator and output collector and reporter. These are the differences. We'll see these methods later in our course. So in new API, if you want to write a mapper, how do you write? Very simple. Your mapper has to extend mapper belonging to MapReduce package. This is the key type and value type expected by the mapper, and these are key types and value types emitted by the mapper. Same. Map will take expected key type and expected value type and context. Whenever we want to emit key value pairs, we say context.write. But in old API, do you remember how did we emit? By using, let me just show you. Let me just show you my mapper, previous mapper. In my old API, I was using output collector dot collect and I'm passing like this in my old API. But in new API, let me show you the new API code as well here. When I am writing my mapper, context.write key value pairs. Even in my reducer, I was extending reducer and I was saying context.write. These are the key differences between the old API and new API. And wait, I'll be back. So you understood how to write a mapper in NewAPI and also how to write a reducer in NewAPI, and also in the driver code, as I told you earlier, there's a difference. In old API you are creating job conf object. Now it is different in NewAPI. First you create a configuration object and then you create a job object separately. Okay, these are the difference. And similarly, job object dot set map output key class, map output value class, set output key class, set output value class. This is for reducer outputs. Okay, and job dot wait for completion. These are the differences in NewAPI. But the process how the map reduce jobs execute, whatever we have discussed, is same. Now what you can do is you can open the same documentation in the same file, documentation file where there is documentation for ToolRunner. In the same file, I think no, there is one more documentation. Yep. So in the same file you have the example of how to create a map reduce job using NewAPI. Follow documentation and complete the lab. Okay. So once you are done, let me tell you some more things about the mapper. So as we understood earlier, Hadoop attempts to ensure that mappers run on nodes where data is present. So for mappers there is data locality, is it? Multiple mappers run in parallel, and generally what the map will do, map will output key value pairs. Map will take key comma value and output key comma list of values. Then generally mapper may use or completely ignore the key. Till now in the programs which I showed you, the key was totally ignored. So what is the value for key by default? The key by default is a byte offset of the file at which the line starts. So it will give you the byte number at which the line starts. Okay, and the value is the contents of the line itself. By default the key is irrelevant in most cases and we use values. Okay, if the mapper writes anything out, the output must be in the form of key value pairs again. Map also will emit key value pairs. So a simple example, there can be a mapper which will take a key value pair and emit upper of key values. So if key is this one and this one, the mapper will emit capital foo, capital bar, capital foo, capital other, like this. This can be a simple example, pseudocode for a typical mapper. Next, see the explode mapper. Let's assume that my map is getting key comma value. Value will be what? The line, is it? So I can write a mapper where it will iterate over each character in the line and will emit key comma character. So my explode mapper pseudocode will look like this. If my mapper is getting foo comma bar as key and values, it will emit foo B, foo A, foo R. Each character is emitted as values. Similarly, my mapper explode mapper may emit key OTHER. This is an explode mapper example. And filter mapper. Sometimes my mapper may not emit key value pairs. So my mapper may look like this. In my mapper, I might write an if condition. If some condition is satisfied, like here I am checking if the value is prime or not, then only emit, otherwise it will not emit. So if the key value pair is like this, foo comma 7, 7 is a prime, so it will be emitted. Baz comma 10, 10 is not a prime, so for this key value pair the mapper may not emit anything. It is possible that your mapper may filter some key value pairs. And while emitting, the key space can be changed. That means you can emit whatever you want as a key. See here in this case my mapper is taking key comma value, but while it is emitting the value length and value. So in this case foo comma bar, the mapper may emit the size of this value 3 comma bar, size of this value is 5 comma bar, size of this is 11 comma bar. So my mapper may emit any key. It is not mandatory that it will emit whatever key it is getting. It may emit anything. It is all up to your logic. And as we understood, after the map phase is over, all the intermediate values are given to reducer as a list. So we have discussed about all this shuffle and sort already. So the reducer outputs 0 or more key value pairs, and the output of reducer is always returned to HDFS. So example of some reducer, the reducer which we wrote in case of word count looks like this, right? Reducer will get one key and list of all values. So here I am iterating through each value, computing sum of all values and emitting one key comma value. So this is a pseudo code, how it will look like, and this is an example. So if bar comma list of all these values is given to reducer, reducer may emit bar comma 39, sum of all these values. In this case foo colon sum of all these values. This can be an example of sum reducer. And identity reducer, this can be very important for some interviews as well. In some interviews they may ask, what is this reducer? Identity reducer. A reducer which emits key value pair for each value is an identity reducer. So see here, if this is the key value pairs passed to reducer, the value is list of some values, right? So if your reducer is emitting each individual values again, so output of reducer is same as the output of your mapper. If the output of mapper is like this, when it is coming to reducer, for each key the values will be aggregated like this, is it? So if your reducer is outputting key value pairs just like your mapper, then such reducer is called as identity reducer. For the first time whenever you are seeing this identity reducer code, it might be difficult to understand. Just analyze this presentation once, you will understand how this identity reducer works. Okay, so I have shown you some pseudo codes for mappers and reducers. We will dig deeper into map reduce again in next videos. In this video I gave some basics of map reduce.